Welcome back once again. My name is Victor Digomo here, and in our today's class, we are looking at polynomials. We are looking at polynomials, and the the aspect of the polynomial we want to look at is dividing a polynomial of a higher degree with a polynomial of a lower degree. Dividing a polynomial of a higher degree with a polynomial of a lower degree. Okay, that will take us to what we call the remainder theorem. And I have an example to illustrate what I'm trying to say here. Um, if you look at this problem on the board, it says divide 5x raised to power 3 minus 4x squared minus 3x plus 6 by x minus 2 by x minus 2. So if you check out here, you realize that this is a cubic equation. Okay, that's a cubic equation, and we want to divide this cubic equation by this x minus 2. All right, how are we going to do that? You realize from just what we call long division, that sometimes you can have something like let me take for instance 27 divided by 5. Okay, so this 27 divided by 5, you can put it this way. This is 27, and this is divided by 5. This is divisor. Okay, so you realize that if 5 divides 27, 5 can divide 25 that is inside 27 and have 5 remainder 2. So we can have that 5 here. Of course, if you multiply 5 times 5, you have 25, and if you take a subtraction here, the difference will be 2. So this is a remainder. Now I told us that this will take us to the concept of the remainder theorem. So this explanation I have given here, I am trusting God it is going to help you to capture what I am trying to explain. All right, let's move on. You realize that I will apply the same procedure here. I have 5x raised to power 3 minus 4x squared minus 3x plus 6 divided by x minus 2. Here we go. If x, you just have to know some of the things we do in mathematics. You may ask us why. Yeah, it's your right to ask why. So, but sometimes we just give you an idea and present a procedure that you need to follow. And of course, when you follow that procedure, you get to the right destination. So if what we do here, like my students will ask, why are we not using the 2 to divide this at once? And we say that you use this alone. Okay, so look at this. X divide this. Just follow the procedure. This x divide this, the first term there, it will give us 5x squared. Okay, this is x raised to power 3. This x divide this, it will give us this. I will not just assume that everybody there knew what I'm talking about. Let me take a step down a little bit, but I will not do it after now. Okay, I'll not do it again. So this is 5 times x times x times x divided by x. So you see this takes away this. It's remaining 5xx. That's 5x squared. I'm sure you got that. All right. So you use this and multiply this. This times this, that will be 5x raised to power 3. Okay. Then this times this, that will be minus 10x squared. This times this will give you this. All right, we subtract. You saw me do it when I was doing something here, a demonstration. We take the difference. This minus this will go. That was 0. So now look at this. Minus 4x squared minus into minus 10x squared. I'll do something again which I will not repeat again after now. So look at this. I said minus 4x squared minus into minus 10x squared. You realize that here becomes plus 10x squared. This is minus 4x squared. So this is like 10x squared minus 4x squared, and that is going to give us 6x squared. I'm sure that explanation is very clear. All right. So what do we have next? We'll bring down minus 3x and bring down plus 6. So we take another procedure again. X divide this. That will give us that will give us plus 6x plus 6x. X divide this. I did a demo previously. Okay, so we have this, then this times this will give us 6x squared. Then this times this will give us minus 12x. Are we together? Hmm? I hope we're following. I hope we're taking it gradually. All right. So we have this. The next is we subtract. What do we have here? This minus this is 0. This minus is going to be plus here. I did a demo. All right. I'm sure that demonstration is going to help us to capture what I'm trying to explain here. So this becomes plus 12. And you are looking at 12x minus 3x. And that is going to give us 9x. I will bring down plus 6. All right. I'll take again another procedure. This divide this. That will give me plus 9. Plus 9. Okay. Plus 9. I will multiply it again and I'll have 9x. This, am I correct? Yeah. This is minus 18. And when you subtract again, you will have 0 here, and this is going to be plus 18 plus 6. That will give us plus 18 plus 6. Plus 18 plus 6 is 18 plus 6, 24. 24. 24. I hope everything I did here is correct. Let me verify again. Here, here. Okay. 9 times 2 is minus 2 is minus 18. We subtract minus into minus is plus. Into this is yeah, plus 24. Okay. 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 All right. Now we have succeeded in dividing this expression by that. We have succeeded in dividing this by this, and we have a remainder. We have a remainder. All right. This, as I said, is going to bring us to the remainder theorem. What does the remainder theorem say? The remainder theorem says given f of x, okay, given f of x, that if this f of x is a polynomial of a certain degree, higher degree, and it is divided by say x minus a. If it is divided by, take for instance, x minus a, that you will obtain, it results to a g of x. It results to a g of x and a remainder, and a remainder r, okay. So you realize that this thing can be expressed as f of x over x minus a will give g of x plus r which is yet to be divided by x minus a. Do we get? So this is what the remainder theorem is all about. And this is a typical demonstration of it. We get? So if you, yeah, because this now, this expression, this thing here can be demonstrated in this form. This is the function f 5x raised to 3 minus 4x squared minus 3x plus 6 being divided by x minus 2. It gave us a result. The result is 5x squared plus 6x plus 9 plus a remainder 24, which is yet to be divided. No, you are still dividing this by, still dividing this 24 by this. A remainder which is yet to be divided by that. So this is a way to explain or explain the remainder theorem. Of course, if you multiply through here, if you want to return back to this, multiply through here by x, multiplying through by x minus a, you will have x, this times x minus a will give us the original function f of x equals to, this will be g of x dot x minus a, then plus, this will become plus r. Okay, so this function now we can express it in this form, and that's what the remainder theorem is talking about. So I believe we have been able to, you know, explain some things here, and I so much believe that this explanation will so much help you to, one, understand the remainder theorem, and two, understand how to divide a polynomial of a higher degree by a polynomial of a lower degree. All right, we are going to the next class take a look at how one can be able to factorize a cubic equation. You know, this is a cubic equation. Yeah, we want to look at how, if the possibility is there for a cubic equation to be factorizable and the condition under which it can be factorizable. That's the next class, please. One is that if you, I would desire you subscribe to the channel by just clicking on that button below there. One is, the reason is because if you do, you can access so many classes we've had online already. And secondly, you'll be able to know when we are making our next upload. So thank you so much for being there.